All right, selecting procedures for calculating derivatives. So this is kind of an add-on to this unit, but the AP tests ask questions like this, and this is a section in the College Board's unit plan for AP Calculus. And so I just wanted to show you what some of these questions look like so you can recognize them when you see them in my AP reviews and on the AP test. So this is called selecting procedures for calculating derivatives. So number one, which of the following does not require the use of the chain rule to find dy dx? And so what they're looking for here is you to recognize when you have to use the chain rule and when you don't. So anytime you have a function inside of another function, that requires the chain rule. So this one definitely requires a chain rule. And then you see that also here in D, that you have x plus y inside of the cosine, definitely requires a chain rule. Now, B and C, neither one of those look like a function within a function. And if you look in C here, you can use the power rule on 3x squared, you can use the power rule on square root of x, and you can write 2 over x is 2x to the negative 1, and you can use the power rule there. Therefore, this one does not require the use of the chain rule. Now, when you look at B, you don't immediately see a function within a function. However, you have to remember that when an equation has both x's and y's, it is assumed that y is implicitly a function of x, and therefore we use implicit differentiation. So for example, when you do this derivative of 4y squared here, you're going to do 8y dy dx, because we're taking a derivative with respect to x. That is using the chain rule right there. And so we need the chain rule, we need the chain rule, we need the chain rule. We do not need the chain rule to do part C. On to number 2, which of the following could be used to find the slope of the line tangent to the curve? Inverse tangent x minus 2y plus 2 is equal to x squared minus 3y plus inverse tangent 2 minus 1. So another example here where we're not actually asked to find a derivative just kind of like above, but here we're just asked to figure out which one of these equations would be along the process of finding the derivative of the slope of the tangent line. So what I would do here is I would just jump into actually trying to find the derivative and see which one of these shows up here. So on the left-hand side, we know the derivative of inverse tangent is 1 over 1 plus the inside squared. And you see that showing up in A, B, and C, which likely means that D is not the correct answer because there should be a squared there. Then I have to multiply by the derivative of the inside by the chain rule, which would be 1 minus 2 dy dx, because the derivative of x is 1, the derivative of negative 2y is negative 2 dy dx. And then on the right-hand side, I'm going to take the derivative of x squared and get a 2x, derivative of 3y and get a minus 3 dy dx. And inverse tangent of 2 is a number. 1 is a number. Those derivatives are just going to go away. All right, so now if you look at what I have here and compare it to these choices, I believe what I have here is choice C, right? If I just move this up into the numerator, so it looks like once again C. So that one, they don't want us to actually solve it for dy dx, which you may have noticed would be very tedious to do, because that's kind of a mess, but we're just picking essentially a step along the way. And again, so these are just kind of interesting questions that they will occasionally ask on an AP test. And then on 3, determine whether the function is a product, a quotient, or a composition of simpler functions. Then determine which derivative rule should be applied. Well, this one's fairly straightforward. This is a function inside a function. So this is what we call a composition of functions. And whenever there's a composition of functions, you must use the chain rule. The chain rule is specifically for compositions. On B, we have a quotient. And so obviously we're going to use the quotient rule. Note that it doesn't ask us to find the derivative, it just says determine which rule should be applied. And then on C, we have a product, and thus we will use the product rule.